Okay, so let's talk about outliers in your data and what you can do about them. In this part of the book, we're talking about an outlier in a single measurement. So you take n measurements of the same thing, and if you have an outlier, what can you do about it? So the question is, can I just ignore it? It's very tempting to throw out data that doesn't look good. But the answer, of course, is no. You have to be ethical about this. The reason we take data is to see if we get funny-looking data. So you must document it, and if you delete it, be clear about that. Put a footnote, mention it in your report. So how do you know if you can throw some data point out? So one way is to calculate the average, take n samples and average them, and then if the measurement is too far away from the average by some measurement, then we can eliminate it. So the question is, what is too much? How do we figure it out? It has to be statistically significant based on the measurements you've taken, and so we're using this technique called the modified Thompson Tau technique that's in chapter 6 of our book. So here's some sample data. So there are 9 samples measured here in this set, so 1.2, 1.2, and so forth. And then they're graphed here. This is the value, and just based on, they're all measuring the same thing, so they're lined up here. And the question is, can you spot the outliers? Your eye is a good indicator of what's an outlier. So you can see this one way up high, maybe this one down here might be outliers compared to the ones in the middle. So you can spot them. So definitely plot them and look, make sure you see an outlier. But you can't just throw them out based on that looking bad. So here's the Thompson Tau technique. Of course, we're using a table because it's chapter 6. So given n samples of the same thing, you calculate the average, x bar, and the standard deviation, s. Then using table 6.8, find the Thompson Tau, and it's just a function of n. There are 2 columns, n and tau, and then it wraps around, more n and more tau. Then, and this is important, for each data point you measured, you calculate the deviation, which is the difference between the measurement and the mean. Take the absolute value, so we're just finding the positive deviations here. And then for only the largest deviation, you check to see if you should throw it out. So the test is if your deviation is greater than tau from the table times s, the standard deviation of your data, then we should eliminate that data point. But you only do it one time, and because after you eliminate the data, you'll have a new n, it'll be 1 less than your original set. You'll have a new average, because you'll have thrown out the outlier, you'll have a new standard deviation. So you eliminate a single point, calculate the new statistics, and then start over with the next largest deviation. Okay, so here's an example using that data that we looked at. And so if we calculate the average, it's shown here with the red circle, 1.13, calculate the standard deviation, and then find tau. So we have 9 samples, so over here our tau is 1.777. Now for each data point, we calculate the deviation from the mean, and find the largest deviation and apply our test. So in this case, our largest deviation is 0.4611, which is when x equals 1.6, this point up here. And our tau s is 0.4066, so we do get to eliminate this outlier. And we can only eliminate the one. Now we go back and we have a new set of data. Now we have 8 samples. We've eliminated this one. So we're over here. This is our new set, elimination round 2. We get a new mean. We get a new standard deviation. We get a new tau because our n is now 8. We calculate again all the deviations and check the largest. So our largest deviation is 0.2812. It's this point down here. Our tau s is 0.2802 for this new s and new tau. So just barely we're eliminating this one. if we looked at the previous tau s, we wouldn't have eliminated it. So you have to calculate each time for the new set of data. Okay, now we're on to round 3. This is our new set of data. Now we have 7 points. And these are the new set of data with the ones we've eliminated crossed off. We get a new average, shown here in red, new standard deviation, new tau, because we now have 7 samples. And again, we calculate all the deviations and find the largest one. In this case, it's 0.1786 at x equals 1.3, this point here. Tau s is 0.2087, and so we're done. Nothing more to eliminate. Okay, well, that's the Thompson Tau technique. It's an impartial method to judge what an outlier is and whether we can discard it. And it gives you a citation and an arbitrary reference so people aren't thinking you're cooking your books. And it's important to remember to just eliminate one outlier at a time, and then you have to recalculate the statistics. And you can make a statistically significant other joke.